Hello everyone. In this video, we'll see how Zscaler AI Guardrail can protect the workflows between AI client and the enterprise-hosted private LLMs. In the previous two videos, we covered agent-to-public LLM communication. We saw MCP agent connects to Box and Git MCP servers, get raw data. Sensitive information was redacted and the sanitized result was stored in the Git repo. We then turned on Zscaler Client Connector, which forced traffic for public LLM to go through Zscaler Internet Access and Zscaler AI Guard instead of going direct. We applied and tested guardrail prompt and response detectors. Both of these scenarios cover public LLM. In today's video, we'll cover how AI agent talks to the private hosted LLM. Zscaler AI Guard in the API mode integrates with LiteLLM, provides the same protection as we saw in the last video, but this time with agent talking to a private model. For this demo, I am running Llama 3.2. So here are the detectors I'll use for this demo. For the last three detectors, since the prompt action is set to block, there will be no response returned. For the first two detectors, when the action is detect and allow, a response will be generated and then evaluated against the response detectors. The agent sends the prompt. LiteLLM forwards it to the AI Guard for prompt detection. If the AI Guard does not block the prompt, it is forwarded to Llama. Llama then generates a response, and the LiteLLM forwards the response to AI Guard, where it's evaluated against the response detectors. If the response is not blocked by the detector, it is forwarded back to the agent. Let's issue our prompts. So this is my Gemini client from where I'll trigger several prompts. At the bottom is my LiteLLM, which makes API calls to the Zscaler guardrail, and on the top left is where we will see Llama logs. Here is our first prompt for getting the financial advice. LiteLLM makes an API call to AI Guard. The prompt is allowed. Here, direction in means that it's a pre-call inspection of user prompt. The prompt is forwarded to Llama. In this case, AI Guard policy blocked the response. This works as expected. Now let's issue our second prompt to get competition information about Cisco products. LiteLLM makes an API call to AI Guard. Competition prompt is set to detect. The request is forwarded to Llama, which responded, and the response is forwarded to the client, since in this case, the prompt and response are both allowed. Here is the pre-call inspecting user prompt, and here is our post-call inspecting Llama response. Here is the prompt that we issued. These are prompt triggers configured in the policy. These are the response triggers. Here's the response from Llama. The competition trigger is true with a high confidence score for the keyword contained in the policy. This is the only trigger where policy allows both the prompt and the response. For the last three triggers, the policy is set to block the prompts, so there won't be any response generated. Here is the PII deep scan prompt. It's blocked right away, which is what we expected. Let's now trigger prompt injection. The policy is set to block. Let's now run our last toxicity prompt. As you see, it is blocked right away as configured in the AI Guard policy. Let's now hop onto AI Guard portal and verify the logs. Toxicity, prompt injection, and PII deep scan were all blocked. This is the high confidence score with which these triggers were blocked, and they were all blocked in the in direction, which is the pre-call for inspection of user prompt. For competition, both prompt and response are allowed. Here is the prompt in the pre-call, and here is the post-call, where we see the response from Llama, which was forwarded to the agent. So that wraps up our 3-part series on AI security. We covered how legacy data protection tools are not sufficient in the AI era as we shift from semantic to intent-based security. We explored securing MCP client workflows and protecting both public as well as private LLM deployments. AI innovation must be matched with AI native security, and this is where Zscaler AI Guard plays a critical role. It's a high-fidelity AI runtime protection solution that delivers end-to-end inline visibility and control across AI apps, agents, and LLMs, blocking threats in real time. Built to secure AI enterprise applications, it enables organizations to adopt AI with confidence. So I hope you find the content presented in this series useful. Subscribe for more AI and security insights. Thanks, and see you in the next one.